In the first half of this video, we will look at the biggest, largest, tallest wind turbines in the world, and in the later half of the video, we will explore why the wind industry is making these huge turbines and what the future holds for wind turbine design. This list only contains turbines that physically exist. It does not include turbines that are being designed at the moment. So let's begin with the top 5 wind turbines. At number 5, we have the Mingyang SCD 6.5. This turbine is the biggest two-bladed wind turbine in the world that was designed and built by Mingyang Wind Power in 2013. At peak power, this turbine produces 6.5 megawatts. The SCD 6.5 is an offshore downwind turbine designed by Aerodyne Energy Systems. It has a lightweight permanent magnet generator and it is adapted for China typhoon weather conditions. At number 4, we have Samsung S7171. The rated power of Samsung S7171 is 7 megawatts and the rotor diameter, as indicated by the name, is 171 meters. Samsung, the phone giant, also has a heavy industry division. Although Samsung's main wind energy product is the 2.5 megawatt horizontal axis wind turbine, but it has ventured in the larger wind arena. One of Samsung's S7 prototype wind turbine is located in Metal 5, Scotland. At number 3, we have the Enercon E126. Enercon E126 is a turbine that can generate up to 7.58 megawatts energy. At the time of its launch, it was the biggest wind turbine in the world, and it is still the biggest direct drive turbine in the world. Direct drive means that there is no gearbox in the design. What makes this turbine unique compared to other turbines is that it has a very high hub height with relatively shorter blades. The idea is that the turbine would apprehend wind at a higher elevation where the quality of wind is much better. The turbine has a hub height of 135 meters, the rotor diameter of 126 meters, and a total height of 198 meters. At number 2, we have Siemens SWT 8-154. Siemens SWT 8-154 is a 8 megawatt wind turbine. So far, there is only one working model of this turbine. It has a rotor diameter of 154 meters, a swept rotor area of 18,600 meters square. Siemens has plenty of experience in the wind industry and produces turbines for all categories of wind condition. This turbine can be employed offshore. At number 1, we have the Vestas 164. The Vestas 164 is the top of the line in the wind industry. As indicated by its name, the rotor diameter of this turbine is 164 meters. The swept area of the turbine is a whopping 21,124 square meters, and the nameplate capacity of this turbine is 8 to 9 megawatts. The maximum tip height of the turbine is 187 meters. The blade diameter for the Vestas 164 at the root is an amazing 4.6 meters. At this size, it would easily allow a London bus to pass through it. It is an offshore wind turbine, several units of which have been already installed in Burbo Wind Farm off the coast of England. And that completes the list. Now let's look at what the future holds for the large-scale wind turbines. The wind industry has been shifting towards larger wind turbines over the past decade. The commercial wind turbine manufacturer kicked off their design rated at 750 kilowatt turbines and soon moved towards 2.3 megawatts. 3 years later, the industry gravitated towards 3.2 megawatt wind turbines. Today, the wind industry is still looking upwards. There are a few reasons for this trend. They are as follows. Number 1, the turbine design has improved. With more insight into materials and its behavior in real-life windy conditions, engineers have now been able to design longer, more rigid and fatigue-resistant blades. Number 2, the direct drive option has eliminated the need for a gearbox. The gearbox maintenance is an essential part of wind turbine servicing. The gearbox failures can account up to 18% of the incidents that render the turbine non-operational. The taller the wind turbine mast is, the more limited are the options for maintenance. Bigger cranes are needed, accessibility can become a major issue. and therefore the elimination of gearbox in the nacelle has allowed the large-scale wind turbines to move offshore. Number 3. Having fewer very large-scale wind turbines in a wind farm makes a more robust system overall than having several medium to small-scale wind turbines for the same nameplate capacity. Number 4. Very large wind turbine intercept wind at a higher elevation. With rising altitude, the quality of wind improves. The industry is already looking towards 14 to 15 megawatt wind turbines. New challenges are also emerging. For example, the taller the wind turbines are, the more they will be struck by lightning. Hence, very large wind turbines are also looking into lightning protection. And this concludes the video.